Hello friends, today I will discuss the super mesh analysis problems with dependent sources. The first problem is find the current I in the following circuit with a dependent voltage source using the super mesh analysis. So look at this diagram here. This is the 18 volts DC supply. So there is a 1 ohm resistor and the voltage across that is assigned as Vx and its polarity also fixed like this. This is minus and this is plus. And this is the current source which is common to the first loop and second loop, and its value is 3 amperes. And here there is a dependent voltage source with polarity like this. This is minus and this is plus, and its value is mentioned as 2 into Vx, and this is in series with a 6 ohm resistor like this, and the current flowing in 6 ohm resistor is considered as I amperes. So we want to calculate what is the current flowing through this. So to solve this problem, so we have to follow certain steps. So let me tell the algorithm to be followed or the steps to be followed before solving this problem. The first step is, first of all, we have to find out how many loops are there. So if we consider this diagram, there are two loops that we can find. This is one loop, whereas this is another loop. The second step is assign the loop currents. The third step is assign the voltage polarity across each element and also write Vx equation in terms of the loop current, and also find the or write the current equation for current source which is common to the two loops. Next, step 4 is remove the current source which is common to the two loops. Step 5 is write the loop equations and solve for the unknown current I. So these steps are going to be followed here. First of all, we have to draw the given circuit like this, and then we found that there are two loops. This is one loop, this is another loop, and we assign the loop currents. This loop 1 current, we call this as I1 and is flowing in the clockwise direction like this. And this loop 1 will have the elements 18 volts, 1 ohm and 3 amperes current source. And this is the second loop current, and it is also flowing in the clockwise direction, and we designate that current as I2. And this second loop consists of the elements 3 amperes, this voltage source, dependent voltage source, and a current source called the resistance called 6 ohms. Now, having assigned the loop currents I1 and I2 and with direction, now it is time to give the polarity voltage for each element. So for a DC source, its polarity remains the same, we cannot change. And similarly, the voltage across 1 ohm is also fixed, its polarity is fixed. This is minus and this is plus, so we should not consider this. Next, we have the another element here, that is a resistor. So here I is entering the 6 ohm resistor here. So current entering the passive element, we treat that as positive, and whereas leaving the passive element as negative. So this is plus and this is negative. And this is 3 amperes whose polarity is already fixed, so which cannot change or which should not be changed. So we have assigned the loop currents and also we assigned the polarity across various elements voltages, and then next step is remove the current source which is common to the two loops. So once we remove this, the circuit will become like this. Now we write the equation first using this, what is Vx in terms of the loop currents. So look at this, this is first loop and the voltage across this 1 ohm, we call that as Vx because it is given like that, and its magnitude is 1 into the current flowing is I1. So we write I1 into I1 and we say that is equation 1. Next step is, so we know the current source here, we have to mention this current source in terms of the loop currents. So if you look at this 3 amperes, the 3 amperes current direction and the I2 current direction, that is loop 2 current direction, are one and the same, whereas loop 1 current I1 is opposing the 3 amperes current direction. So we write I2 minus I1 as the current which is equal to the 3 amperes. That is like this, I2 minus I1 is equal to 3, and we say that is equation 2. So now we have removed the current source which is common to the two loops. Now the circuit which we get here, we call this as super mesh circuit. For this super mesh circuit, we have to write the loop equation. So if you look at this, there is only one loop that comes here, and remember this I1 remains same and this I2 remains same in this loop. So now we have to write the loop equation for this super mesh circuit. So in a current direction assumed, in the loop 1 current direction assumed, that is I1 enters here, next leaves here, and the polarity of the voltage source remains same. This is positive but this is negative, and when we move in the direction of current assumed, that is in the direction of I1, first getting negative plus next plus, so means we treat this as voltage rise, so it will get the positive sign. So we write here plus 18. Next, in the assumed current direction I1, the voltage across 1 ohm is Vx, and first we are getting negative terminal, next we are getting positive terminal. So going from negative to positive in the assumed current direction, we call that as voltage rise, and voltage rise polarity we take as positive. So we write plus Vx like this. Next, there is another element here 2Vx, and its polarity is also fixed. It will not change with the assumed current direction in the loop 2. The assumed current direction in loop 2 is again in the clockwise direction. In the assumed current direction, first we are encountering negative sign, next positive. Going from negative to positive in the assumed current direction I2, we treat that as voltage rise, and voltage rise will get the positive sign, so we write plus 2Vx. Next we have the 6 ohm resistor, and here the polarity is already fixed, so going from positive to negative we call that as voltage drop, and voltage drop will get the negative sign, and the voltage drop across the 6 ohm resistor is nothing but 6 into the second loop current, that is I2. 6 I2 with minus is the value here. So we have covered this element, this element, this element, and this element. There are no elements from here to here, and we say algebraic sum of the voltages in a closed circuit is equal to 0. So we equate this equal to 0. So once this is over, we can further simplify this and we get like this: 18 plus 3Vx minus 6I2 is equal to 0, and we say this is equation 3. So we know equation 1, that is Vx is equal to 1 into I1. So that we called as equation 1. So that equation 1 we substitute here in the equation 3. So that is, in place of Vx we substitute 1 into I1. Once we substitute it, we get like this: 18 plus 3 into 1 into I1 means 3 into I1 minus 6I2 is equal to 0. Then we can further simplify it like this: 3I1 minus 6I2 is equal to minus 18, and we say this is equation 4. So to simplify further, what we do is we multiply equation 2 with 3 and then we add equation 4. So once we multiply equation 2 with 3, that is, equation 2 means this I2 minus I1 is equal to 3. So we multiply that with 3, then we get 3I2 minus 3I1 is equal to 9. So then add the equation 4, that is this. So you bring this minus 6I2 here, then plus 3I1, you write like this, then equate that to minus 18. So now add these two. Once we add this minus 3I1 plus 3I1 will get cancelled. Then we get minus 3I2 is equal to 9 minus 18 means we get minus 9. So we can write then 3I2 is equal to 9. So then I2 is equal to, we say 9 by 3. 9 by 3 means we get 3 amperes. So this I2 is nothing but this current, and that is also equal to the current flowing in the 6 ohm resistor which is given in the problem. So we write I2 is equal to 3 amperes.